Hello everybody. Today we are going to prove that this shape is actually a rhombus. So when it comes to proving a shape, it's more than just looking at it. This might be a square, it might be a parallelogram, so we have to find out the details about a rhombus. So first thing that we need to realize about a rhombus is all four sides are congruent. So we need to prove that. But the problem is the sides are diagonal, so we are not able to just count them. So we have to use Pythagorean theorem. So you can always make a right triangle out of anything. So if I could come right here and I want to check the length of this segment, I'm just going to go down, and that is a length of 2. And I'm going to go across from -2 to 3. That's a length of 5. Your goal is to find out what Gj is. So we're going to do a squared plus b squared equals c squared. And you will find out that you will get 29 equals c squared, and just take the square root, which is just going to give you square root of 29. So the square root of 29 is a little longer than 5, but that's fine. We'll just write square root of 29. So students ask me all the time, how much work do I have to show? Is this enough to prove that all of these are square root of 29? So what I would do is I would just make the triangle, and you'll see that from 2 to 4 is also a length of 2, and that from -2 to 3 is also a length of 5. So if you did this again, you will get the same thing. So if you can show me that all 4 of these triangles are the same, then you can say in your explanation that all of the segments are congruent, which is true. So I'm just going to go ahead and write square root of 29. Just make sure to state it. So you can write it in words, you can show it, you can write the triangles, just something to show me that. Next thing that we're going to do is we're going to look at diagonals. For diagonals, you're just going to draw lines that bisect each other across your shape. So in your picture, they're not going to be drawn for you, but I just went ahead and I did that. So something about diagonals of a rhombus is the fact that they're perpendicular. And to prove that, we need to show that this slope is the opposite reciprocal of this slope. But I hope you see that we're running into a problem, because whenever you have a line segment that is vertical, the slope is undefined. So for Hj, my slope is undefined. And then my slope for Gi, so think of slope as how steep something is. If it's horizontal, it's 0 because it's completely flat. So Gi, the slope, is 0, thus perpendicular. This is the only strange example where you can get undefined and 0. So let's say that this was a half. That means that this would have to be -2 over 1 in order for it to be perpendicular, because perpendicular means opposite reciprocal. So we have shown that we have 4 right angles, and we have proven that it's a rhombus. But the only other question is this a square? Because a square also shares all of these properties that we just discussed. So an easy way to check if this is a square is to see if the diagonals are congruent. Because in a square, diagonals are congruent. In a rhombus, they're not. And this one, once again, is a nice example because you can actually count. So from G to I, which is from -2 to 8, is a distance of 10 units. And then from H to J, look at your Y's, you're going from 0 to 4. So this, from here to here, is a distance of 4 units. And I'll make sure to make it in black so you can see that that's the 4 units. So as you can see, the diagonals are not the same, so it's not a square, and we conclude that it's a rhombus. That's pretty much it. Thank you very much.